anyone got any idea why we might have veins in the dike? Sorry?
Some other circulation of water.
So it could be another intrusion. So often you have veins forming much later on. But if that was the case, you'd probably expect to see them throughout the entire back of the sandstone. So yeah, so it's mineral precipitation. So as well as the basalt comes up with the molten rock, and it solidifies to form what you can see here, but you get these residual fluids which aren't included. They don't form part of the basalt. So instead, they kind of precipitate into these cracks that you get at the edge of the basalt. So you get these veins here. Originally, they will have been part of the molten rock and will come up and then they're precipitated into the cracks that form due to cooling at the edge. And that's why you get them at the edge and not necessarily in the centre.
Sorry, why was it more at the edge?
More at the edge because you know how we said that you've got this hot body coming into a cold one, and that causes the cracking at the edge.
Oh.
So basically, they're just precipitating in their cracks that form because of the cooling. So they're just basically filling in any space that they can, and that's where the space is available. Where about is that the last?
Yeah, it was.
It's all so basalt is just a composition, it's a type of volcanic. Yeah, so basically this
Y esto fue que
basalt
por la intrusión magmática en sus
intruded through cracks in the sandstone.
That's the same way the other one intruded. Because of fractures.
Yeah, so originally this whole gully would have been a very narrow fracture, and it would have been under kind of extensional stresses, and that would have essentially pulled the two sandstone sides apart, and that allowed the basalt, molten basalt, to come up and solidify. Obviously, this is just a lot bigger than the one we saw back
So that means it's just the difference in size then?
Yeah. I suppose because it's
How do you
a
call this?
veins.
Why we cannot see veins on the other side?
So this side, what you can see here, this is part of the sandstone, which is probably why it doesn't look the same. But part one says, why is the ridge? What's the ridge made of, and why should it stand up like this? So this is the ridge, which kind of runs that orientation, and this is a sandstone. So if you've got fluids, the fluids that form the veins within the basalt, they're also likely to penetrate into the sandstone itself. So one of the reasons why the ridge might stand up is because those fluids have formed cement, so you might have quartz or calcite cements, which has hardened the rock. But the other reason is because it's right next to this very hot basalt, so it's a bake margin, and basically that hardens the rock as well. So it could be because it's cemented or because it's just baked. So I suppose the bake margin is a type of very small-scale local metamorphism. So it's just hardened the rock. You can also see there's quite a lot of veins running through there.
Yeah.
So they might have formed because of the dike intrusion, or they might be.
So the petrophysical properties of this in this kind of sandstone is poor compared to the normal sandstone, I suppose. I guess.
Probably, yeah. So if you've had a fluid come up and it's formed a cement in the sandstone, that will have filled in the porosity permeability. So that will, yeah, so it'll reduce your reservoir quality. But then if it's intruded into, for example, a shale, and it's infilled that and it, tightened it even more, then that could improve your cap rock quality, for example. So.
Okay.
So I guess we need to move on relatively quickly, but if you'd want to have a quick look around at the, have a look at the margin there. We might have to go, so the tide's coming in, so we might have to go back round to locality 3 and then along.
Oh my god.
It's a challenge.